Good day, everyone. So we will discuss today the fundamental concepts of chemistry. And this is all about matter. So we know that people are born with a natural curiosity about the world. When you were still a kid, you have so many questions, right? The different colors, different textures, simple and complex objects. Those things that move and things that are permanently fixed, you have whys or how's it happens. So as you grow up, you learn to name observable things and as much as possible to figure out how they work. And that is actually chemistry. Why? Because chemistry is one branch of knowledge that grew from human curiosity about the world. Okay, so let us first define chemistry. So chemistry is a branch of science that deals with the study of matter, its composition, structure, properties, and the changes it undergoes. Now, there are five branches of chemistry. First one is the organic chemistry, which is the study of essentially all substances containing carbon, like methane, ethane, lycopene. These are organic compounds that come from living things. All right? The next is inorganic chemistry, which specializes primarily in substances that do not contain carbon. So these are compounds that came from the non-living things. Okay? And then we have analytical chemistry, which is concerned with the composition of substances. So it's about composition and structure of matter. It's both qualitative and quantitative since you are determining what matter is and how much of it exists. The next one is physical chemistry. It concerns with theories and experiments that describes the behavior of chemicals. So we are dealing with the physical structure of chemical compounds, how one substance reacts to another substance, or what is the end result after you combine two or more substances. And lastly, we have biochemistry. So this is the study of the chemistry of living organisms. All right? Okay, so as we have said earlier, chemistry is a branch of science that deals with the study of matter, its composition, structure, properties, and the changes it undergoes. Now, what is matter? Matter is defined as anything that has mass and takes up space. So everything around us is made up of matter. Okay, so the mass of an object is the amount of matter the object contains. For example, a golf ball has a greater mass than a table tennis ball. They have almost the same size, right? They have almost the same size, the golf ball as well as the table tennis ball. However, the golf ball is heavier than the table tennis ball. So therefore, the golf ball, okay, contains more matter than the table tennis ball. Okay? Okay, so let's talk about composition. So when we say composition, it refers to the study and quantity of the components making up the substance. So all matter is composed of atoms. So what is this atom? Atom is the building block of matter. Okay? It is also the basic unit of an element. So how does it work? So let's say we have table salt. All right? So the chemical name of table salt is sodium chloride, and its chemical formula is NaCl, which means the table salt composition is one atom of sodium and one atom of chlorine. Another example is the milk of magnesium or magnesium hydroxide. So what is the use of this milk of magnesia? It actually reduces stomach acid and it is also used as a laxative to relieve occasional constipation. Okay, anyhow, magnesium oxide or hydroxide has a chemical name or chemical formula of MgOH3. So it shows that milk of magnesia is composed of one magnesium atom, three oxygen atoms, and three hydrogen atoms. Okay? Another one, laughing gas, or the chemical name is nitrous oxide with the chemical formula of NO2. Okay? So this nitrous oxide or laughing gas doesn't make you laugh per se, but it can create a feeling of euphoria, which makes you or which may make you laugh easier, and its primary effect is to make you relax or be calm. That's why it is often used in some dental procedures. Anyway, laughing gas contains one atom of nitrogen and two atoms of oxygen. All right. And our last example, we have the baking soda. Okay. And its chemical name is sodium bicarbonate with the chemical formula NaHCO3. So there is one sodium atom, one hydrogen atom, one carbon atom, and then three oxygen atoms. All right. Okay. So structure. Structure refers to arrangement of the components. So all matter such as solids, liquids, and gases is composed of atoms. Okay. However, atoms are almost always grouped together with other atoms to form what is called a molecule. And what is this molecule? Molecule is made up of atoms that are held together. So all of these molecules have their own structures. All right. So here are some examples of molecular structures. So we have the linear, square pyramidal, trigonal planar. Okay, we have T-shaped, seesaw, trigonal bipyramidal. We have the bent. Okay, so you would know more about this when we discuss chemical bonding. By the way, water is a bent molecule. Okay, and diamond is one of the hardest known substances, right? It is a form of the element carbon, and it has a highly ordered molecular structure, or it has a very solid crystal lattice. That's why it is a very hard substance. And then properties. Okay, properties refers to the characteristics that will distinguish one substance to another. So all substances have properties that we can use to identify them, right? For example, we can identify a person by their face, right? Or maybe their voice, height, fingerprints, DNA, and many more. The more of these properties that we can identify, the better we know the person. In a similar way, matter has properties, and there are many of them. There are two basic types of properties that we can associate with matter. So these properties are called physical properties and chemical properties. Okay, so for physical properties, it is a quality or condition of a substance that can be observed or measured without changing the substance composition. And physical properties is categorized into two: the intensive properties, which are those that give a particular substance its unique identity. So some examples of this are smell, freezing point, boiling point, melting point, what else? Viscosity, and a lot more. Okay? And please take note that measuring each of these properties will not alter the basic nature of the substance. Okay? Then the other one is extensive properties. These are qualities which are not characteristics of the substance itself. So this is a property that depends on the amount like mass, volume, length, even shape. All right? These are extensive properties. Now let's have some examples. Okay, so let's try to exercise your brains. So we have two liquids here, water and ethanol. And we have to identify some of their properties, if intensive or extensive property. So let's take a look at this. So we have 100 ml of water, and then we have 100 ml of ethanol, and that is their volume. So volume is actually an extensive property. Now, what about 100 degrees Celsius water? And then ethanol has 78 degrees Celsius, and that is their boiling point. So what type of physical property is this? That is intensive property. Now let's move on. We have 1 gram per ml of water, and then we have 0.79 gram per ml for ethanol, and that is their density. So the type of physical property is intensive property. Okay, next one, we have 100 grams of water, and then we have 50 grams of ethanol. And this is the mass. Okay, so what type of physical property? It is extensive property. All right, and then the last one, we have the colorless for water, and then colorless for ethanol. So obviously, this is the physical property or the color of these two substances. So is it intensive or extensive property? Okay, it is intensive property. Okay, so the colorless liquid that was found to boil at 100 degrees Celsius and has density of 1 gram per ml would be likely water. All right. And then the colorless liquid that boiled at 78 degrees Celsius and has density of 0.79 gram per ml would most certainly not what, but ethanol. Okay. So this shows that physical properties help chemists to identify the substances. Okay. Now, the next one is the chemical property. So this is the ability of a substance to undergo a chemical change and form new substances. So some of the chemical properties include resting. It is the chemical property of iron, heat of combustion, okay, uh, reactivity of a substance with water, pH, or the power of hydrogen, and the electromotive force. So the more properties we can identify for a substance, the better we know the nature of that substance. Okay? So this is the diagram for the properties of matter. And you can identify if it is a chemical or physical property by answering the questions. Are these properties determined without changing the identity of the substance? If the answer is no, then it's a chemical property. But if the answer is yes, then it's a physical property. All right? Now, change. Change refers to the transformation that matter undergoes. And there are three types of changes. We have the physical change, chemical change, and nuclear change. Now, there are two major differences between physical and chemical change. First, a physical change is reversible. A chemical change is irreversible. For example, the freezing of water would be a physical change because it can be reversed from ice to liquid water or liquid water to ice. All right? Whereas the burning of wood is a chemical change because you can unburn it. All right? Now, the second one is the physical change is a change in which no new substance is formed. Okay? While a chemical change results in the formation of one or more new substances. So again, let's consider the previous examples. Freezing water into ice just results in the water molecules which are stuck together and still H2O. It's still composed of two hydrogen atoms and one hydrogen atom. Okay? So there is no production of new substance. Whereas burning wood results in ash, carbon dioxide, oxygen, and so on. So all these new substances which weren't there when you started. Okay? And then the third one is nuclear change. So nuclear change involves changes in nuclear structures such as fission or splitting of nucleus or an atom, or fission, the combination of neutrons and the protons to form heavier atoms. Okay, let's try to challenge yourself. Answer if the given example is physical change, chemical change, or nuclear change. Okay, let's have the first example. Water boils out of a kettle or condenses in a cold glass. So what is your answer? That is physical change. The next one, a silver spoon tarnishes. It is a chemical change since this is the combination of silver and then sulfur, which will form the black tarnish, which is known as the silver sulfide. All right. And then the next is an aluminum pot is put on a burner and gets hot. Obviously, it's a physical change. And then the next one, atomic bomb explosion. So that is nuclear change. And then the last, okay, it already has the answer. So cultured milk and yogurt. So pasteurization, and this is a chemical change. All right, so words such as boil, freeze, dissolve, melt, condense, break, split, crack, grind, cut, crush, and bend usually signify a physical change, while words such as burn, rat, rust, decompose, ferment, explode, and corrode usually signify a chemical change. All right? Now, matter can be subdivided into mixtures and pure substances. So mixture is a physical blend of two or more substances. So most samples of matter are obviously mixture. For example, you can easily recognize chicken noodle soup as a mixture of chicken pieces, noodles, and broth. But recognizing other materials as mixture may be much harder. For example, air. It is a mixture of gases, but its component cannot be distinguished by the naked eye, right? Or even through a microscope. That's why mixture can be classified as homogeneous or heterogeneous mixture. So when we say heterogeneous mixture, this is one that is not uniform in composition. These are substances where the components are visible on the naked eye. Okay, so some examples of this are halo-halo, soil, gravel, and sand. Okay, while the homogeneous mixture is one that has a completely uniform composition in which the individual components of the substance cannot be seen by the naked eye, just like wine, air, salt, water. Okay, now this homogeneous mixture are so important in chemistry. That's why chemists give them special name of solutions. All right. When we say solution, it means homogeneous mixture. So we have the gaseous solution like air. We have liquid solution like wine. And then we also have a solid solution of copper and zinc, which result into brass. Okay. Now, the other classification of matter is pure substances. So these have uniform and definite compositions, and pure substances can be classified into two groups. So we have the elements, which are the substances that compose of atoms with the same number of protons. So these are the substances that cannot be separated into simpler substance by chemical or physical means. So these are the building blocks of for all the substances, and you can see in the periodic table of elements. Okay, so some examples of this are oxygen, nitrogen, hydrogen, what else? Chlorine, bromine, and so much more. Okay, there are actually 118 existing elements right now. Although in your periodic table, there are 127. However, those other boxes are still yet to be supplied or to be discovered. Okay? And then the other one is the compounds. So these are substances that compose of two or more elements chemically combined. So this can be separated into simpler substances only by chemical means. So we have some examples: sodium hydroxide, ammonium hydroxide, chlorine, hydrochloric acid. Hydrochloric acid is also known as muriatic acid. So that is the common name of hydrochloric acid, muriatic acid. Okay? And in the previous example, in the composition, those are also known as compounds. Okay? So everything around us is governed by the law of conservation of matter, which states that matter is neither created nor destroyed. It can only be transformed from one form to another. So one of the first conservation laws to be discovered was the conservation of mass or matter. Okay, so suppose that you combine a very accurately weighed amount of iron and sulfur with each other. So let's say you have 50 grams of iron and then 100 grams of sulfur. The product of that reaction is a compound known as iron sulfide. And if you also weigh very accurately the amount of iron sulfide formed in that reaction, you will discover that it has the same amount as those two reactants that you combine. So it would be 150 grams. So it means whatever comes in comes out. Okay, so that is the principle of law of conservation of matter. All right. So the next one now, a similar law exists for energy. It is the law of conservation of energy, which states that energy is neither created nor destroyed. It can only be transformed from one form to another. So when you turn on an electric heater, okay, let's have a simple one, an oven. The electrical energy is converted into heat energy. So if you measure the amount of electricity supplied to the oven and the amount of heat supplied by the oven, you will find the amounts are equal. So in other words, energy is conserved in the oven. All right. It may take various forms such as electrical energy, heat energy, magnetism, or kinetic energy. Okay, but the relationship is always the same. The amount of energy used to initiate a change is the same as the amount of energy detected at the end of the change. All right? So in other words, energy cannot be created or destroyed in a physical or chemical change. All right? So this statement actually summarizes the law of conservation of energy. Okay? So that's all for today. Thank you and God bless.